This is Kiko's kennel. Look, the upper part of the doghouse is a triangle. What type of triangle do you think it is? Let's find out. First, let's measure the sides of the triangle. From the lengths of the sides, what can you conclude? Since two sides of the triangle AB and AC are equal, it is an isosceles triangle. Next, let's measure its angles. All angles of this triangle are less than 90 degrees, so it's an acute angle triangle. Now, look at the triangle closely. What do you observe about the angles that are opposite to the equal sides? The angles opposite the equal sides are equal in an acute-angled isosceles triangle. Is this statement true for obtuse and right-angled triangles too? Let's take a look. Angle P is equal to angle R. These angles are opposite to sides QR and PQ, which are equal. So, we can say that angles opposite to equal sides are equal in an obtuse angle triangle. Angle X is equal to angle Z. These angles are opposite to sides YZ and XY, which are equal. So, we can say that angles opposite to equal sides are equal in a right-angled triangle. For this statement to be considered a theorem, it needs proof. Let's look at one way to prove this statement as true.
Recall that in an isosceles triangle, two sides are equal in length, and the angles opposite to equal sides are equal. Also, the altitude bisects the vertex angle. Let's now see how to construct an isosceles triangle in some cases, such as when its base and one base angle are given, and when its base and altitude are given, and when its altitude and the vertex angle are given. Recall that in an equilateral triangle, all the three sides are equal in length, and all three angles are equal to 60 degrees. And the altitude bisects the vertex angle. Let's now see how to construct an equilateral triangle in specific cases such as when its one side is given, or when its altitude is given. already learned about equilateral triangles. An equilateral triangle is a triangle in which all the three sides are equal. Let us now draw altitudes through each vertex to the opposite side of this triangle. For an equilateral triangle, all these altitudes are of equal length. Hence, we can define the height of an equilateral triangle as the common measure of the three altitudes.